So, good day, everyone. So, we are tasked to report about the application and processing of metal alloys. So, the reporters are Gabriel A. Escuyos, me, and my partner is Neltroy Romagera. So, let's start. So, introduction. Choosing the material with the right mix of properties for a certain application is often the most difficult part of the material problems. As a result, all participating in the decision-making process should have a basic understanding of the possibilities available. The first section of this chapter gives a quick rundown of some of the most common commercial alloys as well as their basic features and limits. So, types of metal alloys. So, metal alloys are frequently divided into two categories. Um, the two categories are the ferrous and the non-ferrous. So, steels and cast irons are ferrous alloys, in which iron is the primary element. The first topic of discussion in this section is these alloys are their and their properties. The non-ferrous alloys, all alloys that do not include iron, are dealt with next. So, ang first is magsugod ta sa ferrous alloys. So, ferrous alloys or steels and cast irons have iron as their primary element. Most steels have less than 1.0 weight percent Celsius, as well as additional alloying elements that make them more heat treatable, also improve mechanical qualities and or corrosion resistant. So ferrous alloys are used extensively as engineering material because iron-bearing compounds are abundant. Economical extraction, refining, and fabrication techniques are available, and they may be tailored to have a wide variety of mechanical and physical properties. So, mo na kanang kuan ng ferrous alloys na kuan instance kanang gigamit sa material engineering. So, mo na mga kuan. Next, classification of ferrous alloys, steels and cast irons. So first is magsugod ta sa steels. Steels are iron carbon alloys that may contain significant amount of additional alloying elements. There are hundreds of distinct alloys with various composition and heat treatment. The mechanical characteristics are affected by the carbon content, which is typically less than 1.0 weight percentage. Then types of steels, low carbon steels, medium carbon steels, high carbon steels, stainless steels. So ang low carbon steels is kuan nang comprise the majority of numerous types of steels manufactured. Kani siya kay kuan contains kuan less than 0.25 weight percentage Celsius and insensitive to heat treatment. This designed to create martensite. So ang kanang martensite guys kay kuha na siya kanang martensite kay kuha na siya kanang kuan hard form of steel crystalline structure. Yeah, it is named after German metallurgist Adolf Martin. So, mo na ang kuan ni ng martensite. So, commonly mo na yung mga kuan example sa low carbon steels. Next is sunod is medium carbon steels. Carbon content in medium carbon steels range from 0.25 to 0.50%. So, kung sa low carbon steel dili ka abot og less than 0.25 kani siya kay from 0.25 to 0.50. Nya, ang weight niya is 0.60 by weight. These alloys can be heat treated by austenizing. Austenitizing. Austenitizing. So, kanang austenitizing, kay kuha na siya ng one of the heat treatment process of steels and other ferrous alloys, where these materials are heated above their critical temperature long enough for transformation to take place. So, kuha na siya ng imong kuha nun para kuan ba? Imo siyang painiton para kuan pa siya maka-form ka og kuan mga transformation. So, next ay austenizing and quenching. So, ang kaning quenching kay kanang kanang quenching kay kuan na siya ng kuan ba kanang soaking of metal at a high temperature. Kuanon nimo siya nimo siya kuanon din nimo siya sa pinaka ay kanang kuan init nga temperature imo siyang murag liguon or something nga imo kuan sa iyang lawas sa steel. And then heat treating again. Tempering is process that improves the mechanical characteristic of metals. They are most commonly used in tempered form with tempered martensite structure. So next is high carbon steel. High carbon steels with carbon levels typically ranging from 0.60 to 1.4 weight percentage are the hardest, strongest, and the less ductile of the carbon steels. They are nearly usually used hardened and tempered, making particularly resistant and capable of maintaining a sharp cutting edge. So kaning high carbon steel kay kuan siya na mo daw pinaka kuan sa tanan nga mga klase sa steel. Usually kuan siya na example ani niya kay kuan. Ang example ng high carbon steel usually kanang mga cutting tools or mga knives nga na ba manay kuan sa carbon steels, high carbon steels. So next is cast irons have a greater carbon aning kuan lain na po ni siya nga part sa kuan aton ferrous alloys. So ferrous or ferrous lagi. Classification na po na siya sa ferrous alloys. So cast irons na po ta. So cast iron have a greater carbon concentration than steels, ranging between 3.0 and 4.0 weight percent carbon, as well as additional alloying elements, particularly silicon. The majority of the carbon in these minerals is in the form of graphite rather than being mixed with iron cementite. So, for most widely used cast irons, kaning gray, ductile or nodular and malleable and compacted graphite irons. So, start with gray irons. The carbon and silicon contents of gray cast irons vary between 2.0 and 4.0 weight percentage and 1.0 and 3.0 weight percentage respectively. Muna ang gray iron. Next is ang ductile or nodular iron. Before casting, tiny quantity of magnesium and or cerium is added to the gray iron. So resulting in microstructure and set of mechanical characteristics that are significantly different. Instead of flakes, graphite form noodles or spill-like particles. So kani siya before ka mo kuan kay usa ka mukasa ni magkasting nga mukuan na kag magnesium or cerium kuan pa sa kanang gray iron. Next is white iron and malleable iron. This alloy's fracture surface is white, hence it's known as white cast iron. And in most cases, white iron is is employed as a step in the manufacturing process. Next is ang compacted graphite iron. Compacted graphite iron is a relatively new addition to the cast iron family, abbreviated CGI. Uh, kanang kuan mo na ang kaning CGI mo na ang compacted graphite iron. Then mo na kato kaman mo ng mga iron nga CGI kanang mostly mga tubo nga CGI nang naikuan ba nang lisod bitaw matayan nga naman. Carbon occurs as graphite just as gray, ductile, and malleable irons, and its creation is aided by the presence of silicon. Silicon content is often between 1.7 and 3.0 weight percentage, while carbon content is typically between 3.1 and 4.0 weight percentage. So, so manata sa kuan ferrous alloys. Alloys next is ang non-ferrous alloys. Sa type of alloys. All other alloys are classified as non-ferrous, which is further separated into subcategories based on the base metal or distinguished feature shared by a group of alloys. Wrought and cast non-ferrous alloys are the two types of non-ferrous alloys. Wrought alloys are deformable alloys that may be formed through deformation. Because cast alloys are brittle, casting is the most efficient method of manufacture. So classification of non-ferrous alloys. So muna yung mga classification which is the copper, aluminum, magnesium, titanium, the refractory metals, the super alloys, the noble metals. So copper and its alloys. So start sa copper. Since antiquity, copper and copper-based alloys have been used in a wide range of applications due to their ideal mix of physical qualities. Unalloyed copper is difficult to mill because it is so soft and malleable. Nonetheless, it has an almost limitless capacity for cold working. Uh, it also has a strong corrosion resistance in a variety of conditions, including the ambient atmosphere, salt water, and several industrial chemicals. So, manay ka ng kuan, kanang makaresist na siya ng mga kon, mga condition mo na ang copper alloys. Next is ang aluminum and its alloys. Aluminum and its alloys have a low density, 2.7 grams cm cube versus dayon 7.9 grams cm cube for the steel. So gamay ra gyud density ning kaning aluminum ikumpara nimo sa kanang sa katong ferrous alloys nga steel. Good electrical and thermal conductivities and corrosion resistant in a variety of conditions including the ambient atmosphere. Ang nakakuha ning aluminum kay kuan siya kanang indot siya ikan sa good conductor for electrical and thermal ang kaning aluminum. Because of their great ductility, many of these alloys are simple to make, as illustrated by the thin aluminum foil sheet into which the relatively pure material may be rolled. Next is ang magnesium and its alloys. Magnesium density 1.7 gram cm cube is the lowest of all structures of metal. As a result, its alloys employed when lightweight K is issue aircraft components. Magnesium, example lang ng kwan sa kaning magnesium kay kwan kanang mga aircraft components daw. So kay mo kwan man siya gud kanang di kay siya kanang dako density ba. So madari gid siya. Then magnesium is a soft metal with a HCP crystal structure. Unsa man ang HCP? So kuan kanang HCP kay kuan na siya kanang hexagonal closed pack or kanang kuan kanang Kanang HCP structure has three layers of atoms. In both the top and bottom layers, there are six atoms that arrange themselves in the shape of hexagon, and a seventh atoms that sits in the middle of the hexagon. So mo na ang kuan sa HCP crystal structure. And a low dayon and a low elastic modulus of 45 GPa or kuan 6.5 106 psi. Mo na ang magnesium. So next is titanium and its alloys. Titanium and its alloys are relatively new technical material with an unusually diverse set of features. The pure metal has a low density, 4.5 G per cm cube or grams per kwan. A high melting point, 1 1,600 1,668 Celsius or 3,035 Fahrenheit, and 107 GPa or 15.5 106 psi. Elastic modulus, titanium alloys are incredibly strong with tensile strengths as high as 140 APA or 200,000 psi. At room temperature resulting in extraordinary specific strength, the alloys are also very ductile and very easy to forge and manufacture. Next is the refractory metals. Refractory metals are defined as metals with extraordinary high melting temperature. Niobium or Nb, molybdenum Mo, tungsten or ang kwan is W, and the tantalum or Ta are all members of this group sa kwan sa Ta. Niobium melts at 2,468 degrees Celsius or 4,474 degrees Fahrenheit, while tungsten melts at 3,410 degrees Celsius or 6,170 Fahrenheit, the greatest melting temperature of any metal. Next is the super alloys. Kaning super alloys is kuan siya. Kuan siya kuan ikaunom nga type sa kuan sa non-ferrous. Dayon, superalloys features extraordinary combination of characteristics. The majority of the utilized in aircraft turbine combined which must endure prolonged exposure to highly oxidizing condition and high temperatures. Under these conditions, mechanical integrity is vital. Density is a key issue in this regard because centrifugal stresses in rotating parts are decreased when density is lowered. Next is the noble metals. Na mo ni last. So sa kuan first, the noble metals, often known as valuable metals, are collectible of 8 elements that share several physical properties. They are valuable or precious and have outstanding or remarkable noble qualities, such as being soft, ductile, and resistant to oxidation. Silver, gold, platinum, and palladium, rhodium, ruthenium, iridium, and osmium are the noble metals. The first three are the most abundant and are often used in jewelry. Kaning kwan, silver, gold, and platinum. So, miscellaneous non-ferrous alloys, kanin siya kay lahi klase po niya siya sa non-ferrous pero kanin siya ng kanabit ang miscellaneous lang. So, the preceding study covered a great majority of non-ferrous alloys. Nevertheless, there are few more that are used in range of technical application and are worth mentioning briefly. Di lang ni siya wala muro ang anong wala ni siya gikuan pero kasi naalang ni siya like kuan wala ni dili gid miscellaneous lang nila. So nickel and its alloys in certain situations, especially those that are basic, they are very corrosion resistant. As a corrosion preventive treatment, nickel is frequently coated or plated on several metals that are prone to corrosion. Mono, a nickel-based alloy with around 65% Ni and 28% Cu, the rest is iron, is used in pumps, valves, and other components that come into contact with acid or petroleum solutions. And lead tin under alloys. Both nga lead. Both are mechanically soft, weak, and low melting temperature. Corrosion resistant and crystallization temperature below room temperature. Lead tin alloys which have low melting temperature are most frequent solders. May gamiton sa pangsolda guys kanang lead tin. And then unalloyed zinc, a soft metal with a low melting temperature and crystallization temperature below ambient. It is chemically reactive in a variety of typical settings, making it prone to corrosion. Dayon, fabrication of metals. Nanata sa fabrication of metals, manata sa itong non-ferrous alloys. So, karon nanata sa fabrication of metals. The categories of fabrication techniques include different metal forming procedure, casting, powder metallurgy, welding, and machining. Typically, two or more of these must be utilized before piece is finalized. The processes used are determined by a number of elements, the most significant of which are the metal's characteristics, the size and shape of the completed object, and of course, cost. So, money ang kuan mga pamaagi sa pag-fabricate sa metal. Kuan sa forming operations. Forming processes modify the shape of a metal item by plastic deformation. Forging, rolling, extrusion, and drawing are examples of popular forming techniques. Of course, the deformation must be caused by an external force or stress that is greater than the material's yield strength. Most metallic materials being at least moderately ductile and capable of some permanent deformation without cracking or fracture are particularly well suited to these processes. So, start with hot working. Hot working happens when deformation is performed at a temperature higher than that is which crystallization occurs. So, kanang kuan maron mag-melt baron mo ng mga hot working. Next is cold working. Because the metal strain hardens, it increases strength while decreasing ductility. Benefits of over hot working includes a high quality surface finish, better mechanical characteristic and wider range of them, and better dimensional control of completed components. Kung man mo sa hot working, aring pagdadayon sa cold working para mamugahi na po siya. Kung man mo og forma. Next is forging. Forging is a process of mechanically manipulating or deforming a single piece of typically hot metal, which can be performed by blowing or compressing repeatedly. Closed die and open die forging are the two types. Force is applied to two or more die halves with the completed form for a closed die. In a space between them, a metal is distorted. Figure 11.8a. So, anong forging kana na magporma na ka. Next is rolling. The most common deformation method is rolling, which involves pressing a piece of metal between two rollers and reductive its thickness due to comprehensive force generated by a roll sheet, strips, and foil with a high quality surface finish may be produced by cold rolling and extrusion. A compressive force is given to a ram to drive a bar or metal through a die opening. The extruded pieces that emerge has the appropriate form and a decreased cross-sectional area. And next is hand drawing. Tensile force is provided on the exit side of metal component to draw it through a die and with a tampered bore as a result of decreased in cross-section, the length increases. So mo ni ang kuan mga pamaagi niya guys. Ang metal deformation, forging kaning A kani siya forging na dayon rolling kani dayon extrusion kani extrusion and drawing kani awang rolling kay nay circle kani extrusion nay container nya die andere dayon mo ni ram mo ni force mo kuan kay diri kusog extrusion dayon ma-form na nimo din kani siya mo ni ang drawing mo ni die murag ipatunga nimo ang kuan din tensile force. Next is the casting. So casting is a manufacturing technique in which completely molten metals is poured into a mold cavity with the required form. Once solidified, the metal takes on the shape of the cast but shrinks somewhat. Sand casting. Sand is used as the mold material in the sand casting, which is perhaps the most frequent process. Sand is packed around the pattern that has the shape of intended casting to form a two-piece mold. A gating mechanism is often include the mold in the mold to speed up the flow of molten metal into the cavity and reduce internal casting flows. Automotive cylinder blocks, fire hydrant, and massive pipe fitting are examples of sand casting items. Die casting. Ang mga die casting involves forging liquid metals into a mold under pressure and at a reasonably high space, then allowing it is solidify while maintaining the pressure. A two-piece permanent steel mold or die is used with the two pieces clamped together to form the desired shape. The die parts are opened and the cast components is extracted once the metal has set entirely. Rapid casting rates make this cost-effective process. Also, a single set of dies may be used for hundreds of casting. However, this process is only suitable for tiny pieces and low melting temperature. Alloys such as zinc, aluminum, and magnesium. Then sa invest casting, kuan siya ato lang nimo buo na ang invest casting kuan design produced from wax or plastic which low melting temperature investment also known as low wax casting. Dayon when great dimensional precision, fine detail certification and superb finish. Kaning invest casting mo na siyang kuan ginang mura ni siya kanang kanang mukha na siya kanang kuan na siya ba kanang mga mitra kag mura kuan ra plastic or low melting temperature. Then yeah. Then lost foam casting. Lost foam casting is a form of investment casting. The unexpectable patterns in this case is foam. It's a foam that can be made by compressing poly, polystyrene beads into the proper shape and then healing them together to fuse them together. Pattern shape can also be cut from sheets and adhered together using adhesive. The molds is then formed by packing sand around the design. The molten metals replace the design which vaporizes as it is poured into the mold. The compressed sand remains in place and the metal solidifies into the shape of molds. Next, ang continuous casting. Mo ni last kon sa casting. Many molten metals are solidified by casting into large ingot molds after extraction processes. The ingots are usually subjected to primary hot rolling operation, which produce flat sheet of slab which are more convenient shapes and as starting points for subsequent secondary metals forming operation. Yeah, a continuous casting is also known as a strand casting. Produce combines the casting and rolling phases. So, muna ang continuous casting. So, the rest will be reported by Neil Troy or Magera. Thank you.